364 nested list with sum 2. So this problem is similar to nested list with sum 1. The only difference is for the weight of an integer, it's going to be a formula. So the formula is going to be the maximum depth minus the depth of the integer plus 1. So we just need to calculate the maximum depth. So the pattern is exactly the same. So first of all, we're going to calculate the maximum depth, and then we're going to use the formula to solve the problem. Yeah, because the depth is similar to nested list with sum 1. So for this problem with sum 2, we just need to calculate the maximum depth first. So now let's just calculate the maximum depth. So I'm going to prepare a queue. It's going to be the queue. And here I'm going to prepare a maximum depth. It's going to be 0. Now for item inside the nested list, I will append the item with a depth of 1. Now I will check the queue. So I'm going to pop out the node and the depth. It's going to equal to q.pop. Yeah, so I just need to pop it out, or you can pop it from the left side. It doesn't matter, or you can use pop left. It is the same. Yeah. So I pop it out, and I want to calculate the maximum depth. It's going to be the maximum of the maximum depth with the depth d. Now I want to check if it is integer or not. If node dot is integer, yeah, but I want to check if it is not integer, because for the first BFS, I don't need to calculate the final result. I just need to calculate the maximum depth. So if it is not integer, it means it is a list. So for item in not dot, I will get the list, and I will put it inside of the queue. It's going to be this item, and the depth is going to plus 1. Now I already get the maximum depth. Let's just check if everything is okay. I'm going to return a random value result. So I'm going to set the result to be 0. Yeah, I just want to check if my maximum depth calculation is right or not. So the maximum depth for the first example is 2. For the second example, it should be 3. As you can see, the maximum depth is 3. This means my maximum depth is right. Yeah. Now for the second step is that I just want to use another BFS to finish the final result. I just need to copy and paste everything about it. So here, instead of a maximum depth, as I already calculated, I just needed to use a result value. So yeah, I will put a result here, and I put everything inside of the queue, and from here I'm going to check it. So if it is integer, what I'm going to do? So here going to be the else part. So yeah, if it is integer, I want to update the final result. So the result is going to plus equal to the formula. So the formula is here. It's going to be the maximum of depth minus the depth plus 1 times the integer. Yeah, because this is just a weight, and the final return is sum of integer times the weight. So each integer is going to be not dot get integer. Yeah, so I just need to change a little bit and finish the coding. Yeah. Now let me just run it. As you can see, it is okay. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. It's 100%. Now let's analyze the time complexity. It is dependent on the constraints. Yeah, normally the time complexity is n. N is the total number of the node. N is definitely not this nested list dot length. N is the total number of integers. But how many integers? According to the problem, the maximum depth of any integer is less than or equal to 50. it means the integer can be 50. For example, for the first layer, we have a nested list. We have, for example, we have a 50 nested list. And for the inside this one, so this is 50, so inside this one there's another 50 nested list. So it means 50 times 50 for the next layer, and times 50 and times 50. And how many layers? There are 50 layers. So normally the time complexity is going to be really big. I don't know why it works. Normally the depth should be set to 5 or 4, or yeah, because 5 or 4 or 6, because 50 to the power of 5 normally for this 6. If the depth is 6, 50 to the power of 5 should be okay. But currently we are giving maybe 50 to the power of 4 is okay. Yeah, maybe 50 to the power of 4, but the depth is 50. I don't know why it works. Normally it should not work. But anyway, the time complexity is the total number of the integers. I think that's all about it. Thanks for watching. See you next time.